Good day guys, here we are looking at some proofs in trigonometry for mathematics level 4. So with the proof, you are free to start from any side, either from left to right or from right to left. My intention is to do this proof with two methods. I will start first of all from left to prove that the left is equal to right, then later I will come back. So it means I want to start with the left hand side, which is cos 2x. Sorry, it's cos 2x divided by cos x plus sin x. So if I start with this side, one thing that is easy for me is the formula for cos 2x. But you must know that cos 2x is a bit technical because it has got three formulas. Cos 2x can be written as cos square x minus sin square x, or cos 2x can be 2 cos square x minus 1, or cos 2x can be 1 minus 2 sin squared x. So each time you are using the formula for cos 2x, the way you are going, if it is a proof like where I'm going, is supposed to guide you to know which of these three formulas is the best. So since where I'm going contains cos and sine, it means my best formula must be the first option that contains cos and sine. If where I'm going was containing only cos, I will use the second. If it will contain only sin x, I will use the third. So that's how I usually take myself out of the trouble of cos 2x. So here, because of that, we are going to take the first one, since where we are going, the right hand side has cos and sine. So I will write it as cos square x minus sin square x divided by cos x plus sin x. And now the numerator, for it to simplify, I must be able to realize that what is written there is the difference between two squares. If you have a square minus b square, is the same thing as a minus b into a plus b. So with that knowledge, if a is in the place, if cos is in the position of a and sine is in the position of b, then I will just have cos x minus sin x into cos x plus sin x. So the numerator now will simplify to become cos x minus sin x multiplying cos x plus sin x, then I divide that by cos x plus sin x. Then you will now see that this cos x plus sin x will take care of this one, and we will be having cos x minus sin x, which is obviously our left hand side. So that is how I will do it in the first method, where the formula is equal to our right hand side, not left hand side. So I substitute to prove that the left is equal to the right, as you can see. So the other option is where I can start from right and go to left. I just want to show you that a proof, you can start it from any side. It's just that I always prefer to advise students to start from the side that is easier for them. Like, for example, here starting from the left will be easier, because as a level 4 student, you will be copying these formulas from your formula sheet for cos 2x. But if you have to start from the right, you'll be forced to think a little bit out of the box, because it's not easy to look at this and see what to do. But what I will tell you is that when I look at this, I will start by seeing it like a fraction. Then I rationalize my fraction. I know we are used to rationalizing the denominator, but I'll be rationalizing the numerator. So I'll look for the conjugate of the numerator. So it means I have cos x plus sin x. So if I see it as a fraction over 1, then I look for the conjugate of the numerator. Then I use it to multiply numerator and denominator. So you see, it's like I'm rationalizing the numerator. So once I do that, you will now have cos x plus sin x multiplying the 1 to immediately take me to the denominator of our left hand side. So we'll have cos x plus sin x. Then at the numerator, I'm writing cos x minus sin x into cos x plus sin x, which obviously is the difference between two squares. Again, if you are looking at it from right to left, if you are looking at the difference between two squares from right to left, you see that what is here is exactly what is there. This is cos x minus sin x into cos x plus sin x. So it should take us to cos square x minus sine square x on cos x plus sine x. We know very well that cos square x minus sine square x is obviously the formula for cos 2x. So you see, I've succeeded to move from right to left. So I can do a proof from any side. So that is our solution for that proof, guys. So you choose which one is easier for you, whether it's moving from left to right or from right to left. Okay, let's come to the second one and see if we can attempt to do the same thing. We're proving that tan x plus cos x over sine x is equal to 2 over sine 2x. So I want to start with the left hand side, which is tan x plus cos x on sine, which is the side I will obviously advise my students to start with, considering the fact that the formula for sine x, for tan x, is sine x over cos x. I can easily see that formula on the formula sheet. Then plus sine over cos over sine. Then this leads us to a fraction. Each time you are adding or subtracting two fractions, you need the LCD. So if the numbers at the denominator are not the same, if they are different, you multiply them to form your LCD. Then up there, that positive sign must come there. Then what you write here, you take the LCD, you divide the first denominator, you see cos will take care of cos, sine times sine is sine square x. Then with the LCD divide the second denominator, sine x will take care of sine x, cos x times cos x is cos square x, which some students prefer doing what they call cross multiplication for this numerator. Once they get their LCD, they just cross multiply sine x times sine x. You see there cos x times cos x. But that one is very good when you have only two things. And from here now, you see that sine squared plus cos squared, from our basic knowledge of identities, that is equal to 1 divided by cos x sine x. Now, if I check where I'm going, you see that where you are going has a 2 at the numerator, but you don't have the 2. But you can improvise and create the 2 there. So the way you do it without changing anything here is to use the 2 to write a fraction. 2 over 2 is 1, so it's changing nothing in this equation. So if you write like that, you multiply it by 2 over 2. You then have 2 fitting itself freely there in the numerator. Then you have your 2 cos x sine x, the denominator, which for a level 4 student, this is formula number 12, which equals to sine 2x, and that is actually your right hand side. So you see we've moved from right to left, and our proof is perfect. Let's now see what if another student decided to say, I'm starting from right, I don't want to start from left. Then you will get 2 on sine 2x. So the first thing you'll be seeing there is your formula for sine 2x, which is 2 sine x cos x. You get your 2 there, so the 2 take care of itself. You see that 2 can take care of 2. We have 1 on sine x cos x. So usually with the 2 method, 1 must be a bit challenging. That's why I was advising students to handle that one. But there can also be people who prefer this one. Now if you look at 1, it must now ring a bell in your mind that this 1 is the identity sine square x plus cos square x divided by sine x cos x, and since sine x cos x is now like the LCD, it belongs to everyone, so it means I'll be taking sine squared x. So I'm taking my sine squared x, I divide it by sine x cos x, then plus that one, then you get cos squared x divided by sine x cos x. So here you see that this sine x will take care of one of the sine x there, so that I'm left with sine x over cos x, then plus here cos x will take care of one of the cos x there, I'm left with cos x over sine x. So if I look at there, and this is exactly tan x, plus the other term is cos x over sin x, and that is your left hand side. So guys, that's how we've done those two proofs in two methods, starting from left to right and later from right to left. So you have a look at it and then you'll choose which side is easier for you. We are just showing to you that anytime you can start with any side. Thank you very much.